how using TypeScript with your new and existing AngularJS applications can be a benefit to you and your teams. Actually, using TypeScript with any JavaScript application has a lot of advantages. It's not just for Angular 2. Using TypeScript with your Angular 1 applications, you'll uncover bugs that you didn't know were there, and as well, you'll make your code easier to migrate to Angular 2 in the future when and if you decide to go in that direction. A little bit about myself. For the last 2.5 years at Rational FT Services, we have been using TypeScript with Angular 1 and other front-end frameworks. We started using TypeScript when it was new. It was, I think, version 0.4. It was very green and lacking all the nice features it has now. Angular was, I think, 1.0 or 1.1, and definitely Typed was brand new, but we immediately saw loads of benefits once we started using these technologies together. As a developer, I want more confidence that my team is delivering bug-free code and maintainable code. Now, this is something that TypeScript helps with. It makes the code easier to refactor, makes the code safer to refactor. One of the problems with refactoring is if you don't have unit tests and you don't have type safety, you can wind up introducing bugs that aren't caught in QA and make it into production. The type safety in TypeScript helps prevent a lot of those situations. And as well, TypeScript can make your unit tests less fragile. So when you create a class in TypeScript, a service or a controller, the type definition of that class gets exported, and you can import this into your tests. That means when you need to refactor, you need to change the signature of a method. That signature gets exported to your tests. So as long as that test is only testing the behavior of the class and not the implementation, you'll only make the test less fragile by using types. For the last 2.5 years, I'd say one of the big projects we've been working on is a web casino, and we've been using some of the stricter type safety that's offered by TypeScript. Within the TS config, there's a few options you can turn on, like no implicit any, that kind of turns the type safety up to 11. And doing this, we have been catching all of our runtime type errors within development and not QA. This increases productivity, both for developers and for QA engineers. And as well, within CI, we've been catching the data contract type errors. So none of these end up in QA, and of course, none of them end up in production. So TypeScript also gives us long-term productivity. There's a common misconception that dynamic languages are more productive than type-safe languages or statically typed languages. And this comes from 20 years ago. Compilers were very slow. Any application, average application, you'd be compiling for more than 2 minutes. So the development workflow as web developers that we're used to, where you update your code and you see instant results, that didn't work with compiled languages. But this is no longer the case. And this hasn't been the case for some time. Compilers are very fast, and the TypeScript compiler is very fast. So you get to see the results instantaneously. Dynamic languages, when you have a large code base, as the code base gets bigger and bigger, you will need to refactor your code. If you have large teams, you have a lot of independent developers working on different parts of the application, and you will invariably end up with read-only code. You will invariably end up with situations where developers don't want to refactor certain portions of the code. This is something that unit tests definitely help with, and it's something that static types help with. But static types with unit tests definitely help when used together. And along with Babel, Typescript allows you to use a lot of the new ES6 and ES7, I think that's called ES 2016 now. A lot of these new features now. So if you're developing and you're using Babel, you're using ES6, a lot of the code that you'll see in these slides will look very much like the code that you're using in ES6. The only difference is TypeScript is ES6 plus type annotations. And TypeScript allows you to make your code not future-proof. You're never going to make your code future-proof, but it's going to open up a lot of doors to the future. So if indeed there comes a time when you're going to take your Angular 1 project and upgrade it to Angular 2, moving it to TypeScript will make that transition easier. So I just want to clear up a few misconceptions that about TypeScript. I've heard a lot of these misconceptions interviewing JavaScript developers for roles, and one of them is, isn't this just another embrace and extend? Microsoft isn't fighting open source anymore. TypeScript is fully open source. It's under the Apache license. The source code is on GitHub. You can fork it. You can make pull requests. And as well, you install it with NPM. It runs under Node.js. Runs anywhere. The code, any valid JavaScript is valid TypeScript, and the code that the compiler generates will run in any browser. If you've seen TypeScript in the past, you may have seen these very ugly // reference tags. These go away when you use the new ES6 module syntax, or indeed any module syntax. And again, a big misconception is that the common modern web developer workflow won't work with TypeScript. That's not the case. On save, your changes become immediately available. I've never seen a situation, no matter how large a project gets, where you're waiting for more than 2 seconds for a compile, and that can probably even be factored down. And of course, TypeScript is JavaScript. It starts and ends with JavaScript. So, as I said before, any valid JavaScript is valid TypeScript. There are just type annotations that make your code safer that are added to it. So, briefly just about TypeScript support. So on Mac, Linux, and Windows, your favorite editors are supported: WebStorm, Sublime, Vim, Emacs, Atom, NetBeans, Eclipse, and Visual Studio Code, and those run on Mac, Windows, and Linux. And this isn't just simple code completion. This is plugins to the language service. So what this gives you is intelligent code completion, because the editor will, through the language service, will know exactly what type a variable is. And as well, it will know everywhere that a class or a property or a method is used. So this is really what makes refactoring much safer. Because imagine a situation where you're trying to change the signature or change the name of a method in a class called getName. If you do a simple search and replace, getName is very generic. You may have a getName in many different classes. It becomes very dangerous to do refactoring when you don't have statically typed tools. And of course, on Windows, Visual Studio is supported. So I want to talk a little bit about modules. Typescript allows you to use the ES6 module syntax. And one of the historical deficits of JavaScript, at least in the browsers, has been the lack of modules. And this is why AngularJS added their own module system. Fortunately, this module system lacks a lot of capabilities, and that's why they're ditching it going forward. As far as modules, Node.js has very much led the way with the common JS module system. And the ES6 module specification borrows a lot from the Node.js module system. And they go as far as add a few capabilities like asynchronous lazy loading, all with keeping it backward compatible with the common JS, the Node modules. So one of the advantages of using the ES6 module system is you don't get locked into just a single module system. Like say you want to use Browserify, so you decide to use the Node syntax. With ES6, you can use a single syntax and then defer your choice to later. So you can start developing on, say, Webpack, and then later on decide that you want to move to System.js. And really all you need to do is you need to tell Typescript that you want to target a different module system, and you don't need to go and update and change all your module references within your code. So there are other benefits to using module systems, like encapsulation, as well as eliminating a lot of your cruft, like the ifs in every file, where you wrap all your code within a closure. Using a module system, all your code is isolated, so you no longer need to do that. And you can let the Typescript compiler or the module system properly order all your dependencies, so you no longer have to, do that within your gulp or grunt. You can just use the tree, use the module graph to let Typescript or your module loader order those for you. And as well, you can eliminate globals. So Angular's origins were in the day before modules. So as such, the Angular object was attached to the window as a global. Globals are bad. There's always a risk that there's always a vulnerability when you're using globals, but we can sort these out by using modules. So everyone should recognize this bit of code. We've all probably written this. Every Angular tutorial starts out with "this is the bootstrap." And there's a few things wrong with this, but they're not, but it's just the legacy of browsers. Browsers didn't have modules, didn't have proper encapsulation. So the first thing is we're accessing a global. And then the second thing is in in every service, controller, directive, filter, we access the Angular module with this Angular.module app. So it's not so much so bad that we're violating the drive principle, but we're using this magic string app everywhere. And that, I've seen plenty of errors caused by that. And then we have this config, and loads of config would generally be added here at this point, and this would go on and on. But this violates the single responsibility principle. But we can easily sort these out using modules. So now we bootstrap our Angular application by importing the module method from Angular. So this is a method where we create our Angular module. We create our module and then we export it. So we are not accessing anything on the global namespace. And now to access that module, we can just simply do an import. So now we set up our configuration for the routes here. We've moved this, this route config to live where it should live. It's a route config for a login controller, so it should live with the login feature. So now we import the previously defined Angular module, and instead of that ugly, really quick, let's go back. So we have this very ugly dependency injection here in this config. It's very ugly. We all know what it does, and it works great, and it's actually kind of clever, but it's ugly. But we can clean that up by just attaching a inject property on our function. And this is just a much cleaner approach. I think any developer, no matter what their background, they see this, they know what it means. And then we register the configuration with our module. So let's talk about services, controllers, and data transfer objects. So one of the biggest questions I've seen on Stack Overflow is regarding Angular is, do I use factory or service to register a service? You use a service method. The factory method is for registering methods that follow the factory pattern, and that's not necessarily a service. So using the ES6 syntax for services and controllers, your code will be much cleaner, readable, and easier to reason about. And when you add Typescript annotations, it will be much easier to refactor. When you need to refactor, it will be much, and actually the unit test will become, for these classes, becomes less brittle. Typescript will export the API definition of your services to your controllers and other consumers. Your code will know the methods that are available. This will make working with these services in the controllers much easier. So if you simply rename a method within your service, the compiler, the language service will know about it and will update it in your unit tests and then update it in your controllers or other services that consume the API. So here we have a contrived user proxy service. So see here, we're using the same $inject for a dependency injection annotation. And the next line, we have constructor private. So private is actually a TypeScript keyword, and what this does is it will create as a member of the property the $HTTP, and then it will populate it with the value that's passed into the constructor. So it just makes it so it's the same as within the body of the constructor. If you did this $$ HTTP equals HTTP. So it's a nice shortcut. It keeps your code nice and clean. And then we have the public methods of our service here. Nice and unencumbered, very clean, easy to read, and easy to reason about. As well, you may have noticed the second line of this code, we are importing a user login type. This is just a simple data transfer object, or plain old JavaScript object. So let's briefly just talk about how we would use this. So we can define this either as a class, as an interface, or as a type alias. So if it's a class, classes can be newed up. We don't need to new up anything for a data transfer object. So we can use an interface, but interfaces provide us with things like inheritance, and we really don't need that for this. So we can use a type alias. A type alias is just the most simple sort of type definition. So the thing about classes we should know is the classes will actually generate JavaScript code. So there's a cost to using classes here. We don't need this. We don't need any sort of constructor function generated for us. So the obvious choice is interface or type alias. So here we can see we're back at our service, and we are importing our user login type, and we are annotating the login parameter of our login method. Now, so this means that this login method knows what type this parameter is. So if we want to use this type, we can see exactly what properties are there. Now, this isn't making guesses. It actually knows the properties that are available through the Typescript language service. And if we try and use a property or a method or something that's not part of that type, we will immediately get an error. So these issues just never make it into QA. We catch all of these type errors in development, which is what we want to do. So I think something bad happened. So here we have a controller, and within our controller, we're importing our service that we previously defined. So one thing you'll notice is we are not using the var.vm equals this, or we're not adding any methods to the this within the constructor. In a lot of tutorials, that's a common practice. It has a cost. It has a cost as far as memory when you do this. When you add functions directly to this, they are not instance functions, but unique to every instance of a controller. So it's always best practice if you use an ES5 to just add those methods to the prototype. Using ES6, just use classes, and you'll save the user memory in the browser. So, so this very much looks like ES6 code, because it is ES6 code. The only difference are these type annotations. So this just about brings us to the end. We'll just look and see how we wire all this together. So in order to bundle our application together, we need to tell the Typescript compiler every single file that we're using, because these are not, each file, Typescript file, is now a module. So this can easily be automated. So WebStorm and Atom do a real good job of using file globs as an extension of the Typescript config, the tsconfig.json file. But here I'm just going to do it very simply using barrel files or barrel-like files. So with barrel files, you would export everything that you import if you were creating a library. We're not doing that, so we can just import all of our files. So here we have our source /main.ts. So we'll point the TypeScript compiler at this, and for each of our features, we'll do an import of that feature. So here we have login. We may have more logout, foo, bar, admin, whatever the features are. And then within that feature, we'll bring in the controller, the route config. You'll notice that the service that we defined, the user login service, isn't there. Well, we don't need it there because it's imported by the login controller. And then for the tests, we do the same thing. So for the tests, we have a source /test.ts, and we import the test barrel for each of our features. So you could imagine this test file would go on where each of our features, so we'd have /foo, /test, /bar, /test. And then, for each of these, we will import the controller spec, the user proxy spec. And that brings us to the end. So I just want to quickly point out there's a few things I really didn't get a chance to talk about, but they're on this slide here. So the tsconfig, if you're new to TypeScript, you probably want to understand how that works. There's a good getting started on here by a fellow named Bassarat, or that's his handle. And I have a link to the slides and source code on here. And ngForward, I wish I had time to talk about that. So that allows you to use decorators with Angular 1, very much in the style of Angular 2, and a lot of the decorators are somewhat forward compatible to Angular 2. So are there any questions?